Hi everyone, my name is Leong Kai Yao. I'm a third year student from UTHM Malaysia. I'm from the Faculty of Engineering Technology, and today I'm going to present about the FYP1, which is the final year project. My supervisor for this project is Dr. Muhammad Hafizah bin Hanifah. I want to say thank you to him because along this period of project, he gave me so many advice and advice. So the title of my project is the roof shed design affecting pedestrian level wind speed. For background of study, the rapid urbanization and the climate change cause the urban heat island continuous growing in the urban areas. So the urban heat island is an atmospheric phenomenon that the temperature of the urban areas is higher as compared to the rural areas. So obviously the urban heat islands is more apparent at night. So there are many strategies we can use to improve the tendency level wind speed. So one of the ways is use roof shed because the research have found that the roof shed can show the optimum performance in order to improve the tendency level wind speed. The research found that the urban planner and architecture should consider the choice of the roof shed in their project in order to improve the quality of life, since this roof shed is a very useful tool. So among the different factors related to design of building, the roof shed is a well-known parameter that can significantly influence the flow of wind tendency ring around building. For the problem statement, the urban heat islands effect or the heat stress were assisted at the urban area due to the continuous urbanizations on the global warming. So there are many factors can cause this urban heat islands there happen. The low wind speed is occur around the building at pedestrian level due to the higher packing density released from building become lower. This is because the heat cannot release from the building and makes it feel very hot, especially during the night. So that is the reason we have to consider the roof shed will contribute the positive to the wind condition at the pedestrian level. So for the purpose of this study, the roof shed design towards pedestrian level wind speed will be taken as a main element in this research. For the rationale and significance of study, this study is necessary. It is with the purpose to determine the optimum design of roof shed toward the pedestrian level wind speed on the multiple building areas and also the isolated building area. So for this paper is contribute for the area of research by exploring the roof shed application in order to improve the pedestrian level wind speed around building. So the most suitable design of roof shed, it can make an contribution to the field of construction because of its benefits can improve the air ventilation around building, mitigation of heat stress, also the urban heat island effect at the tropical regions, and height of pedestrian level wind speed around building. So after the problem I'm solving, we can feel the cool, especially we don't feel much more hot, especially at the afternoon or night. For objective of a research, the first one is to identify the roof shed design affected to pedestrian level wind speed. The second one is to investigate the effect of different design of roof shed towards the pedestrian level with on multiple building areas by the simulation CFD survey. The third one is to establish the optimal roof shed design towards the pedestrian level wind speeds. For the scope of study, we want to evaluate the effect of different roof shed design on pedestrian level wind speed
around educational building. So we have to do the analysis of the different roof shed on the building with at the energy level wind speed. So it is assumed that the standard KE turbulence model is adopted and 0 degree for the simulations. So in particular, the topographic map in this study assumed to be flat surface and the static condition assumed that without green environment and the human being respectively. The model scale for this study we not possible to explore the urban area at large scale. This is because due to the requirement of the advanced technology, such as the higher computational cost. For literature of review, so we have the advantages of roof shed to pedestrian level wind speed. First one, the roof is an important element of building because it protects us from being exposure of sun and rainings. Therefore, a number of resources have reported that wind conditions around building at the pedestrian level have affected by roof shed. So from this, we know that this roof shed can bring effect to the wind condition around building. The research also concluded that the roof shed significantly influenced the floor topology and turbulence. This is the wind direction and also the flow of wind pattern around building. Based on the perspective from the urban wind environment, it has been established that the roof shed is of building distinctly affected the surrounding wind environment. So there are many type of roof shed can be influence the pencil level wind speed. So there are a few type roof shape that I found in the research. The first one is the gable roof. A gable roof is a type of roof design where the wall upwards towards the two slide slope, which is shown as the diagram above. That enhance the effectively air exchange between the building and increase the turbulent energy. By increase the turbulent kinetic energy, the wind flow will become higher so that it can improve the air ventilation between the building. It has been reported that the performance of a gable roof with a critical roof angle of 45 degree was the best option for ventilation as compared to the flat roof. So it seems that the gable roof is better than flat roof in order to improve air ventilation at pedestrian level. So flat roof is another type that I found. Generally, flat roof or low slope roof are commonly used for commercial building throughout the world. So if we travel to anywhere, so we can find that flat roof is a common. We can see it in any along the commercial building, also the other place. It's concluded the flat roof building at street canyon can improve the ventilation urban areas. So this is the real conclusion from the research. Almost all of the previous study will use flat shape design for their model in order to carry out the analysis of wind flow. This is also from the previous study. It's concluded that both designs show good performance towards pedestrian level wind speed. So based on the table below, you can see that the wind velocity of a flat shape is higher than the gable roof. So this is another type, which is a circle, and we call it as Dump's roof. Unfortunately, there is only a few published studies have a focus on the analysis of Dump's roof. One of the research mentioned that a cylinder wall consist of a spherical roof was identified as the optimum shape for the wind energy exploitation around building. Another research concluded that the ventilations flows become lower and lack of a thermal comfort due to the increasing height of dome shape. So based on these two research, their opinion are different. So it can be concluded the positive result were due to the data of the roof are not applied on the pedestrian level wind speed. Another type of roof, we call it is as pitch roof. Is a triangle, and is a type of roof that comprising a sloping surface with an angle of usually common is 20 degrees. So the prior study concluded that pitch roof can increase the rate of air exchange between the urban area and the outer floor in order to improve the thermal conform. There's been a leader agreement on pitch roof can improve the wind speed and pedestrian level wind speed. This is due to there's only a few published study have focused on this type of pitch roof. This is another type which is step roof. This is the where the surface on the one side is higher than another side. So based on the table of 2.1, which is just now the figure, the table, it shows that the mean velocity of step roof is lower as compared to the other two types, which is the flat and the gable. So we conclude that the performance of step roof is poor towards the pedestrian level wind speed. There's only a few research have focused on this type of step roof. It will be more benefit if they are the more research have focused on this type of roof shape in order to establish the good performance towards pedestrian level wind speed. This is another part from literature review, which is the roof design parameter. So there are basically have four categories. The first one is the building configurations and designs. Building configuration is defined as the overall size and also the shape of the buildings. So we can note that the roof shape of building can be categorized in building configuration because it brings effect to the pedestrian level wind speed. Recently, the research have shown that an increased interest in investigation effect of height of a flat shape building on the pedestrian level wind flow. So another is the roof pitch slope design, which can influence the pedestrian level wind speed. So level study have documented the analysis of wind flow around building that's with different degree of roof pitch. That shows the significant influence on the pedestrian level of building. It has been reported that the performance of a gable and pitch roof building with a critical roof pitch of 45 degrees was the best option to improve the pedestrian level wind speed. So the another is the roof height, which is rise overrun ratios. So in a study conducted by the Hostens 2017, it was shown that the presence of vortex and buoyant force when the rise run ratio, which is the roof height, is increased. So we show that when the roof height is increased, this the presence of buoyance can lead to the turbulence kinetic energy increase, so that it can improve the air ventilations. It still need more explorations of rise overrun ratio on pedestrian level wind speed. Due to there's only a few research have focused on this roof height. For the building aspect ratio, the BADAS 2017 points out that the roof pitch is important for K-on aspect ratio in order to enhance the high-end ventilations around building. Another research has reported that the gable roof with aspect ratio in order to reduce the mean resistance time with a factor of 0.37 as compared to a flat roofs. So basically this reduce of a resistance time can improve the low ventilations around building. It seems that the building aspect ratios with different roof shape can improve the pedestrian level wing. The benefit of good design of roof shape. The first one is the high wind speed or the improve of air ventilation, height of air ventilations. So the Hossen's comparative study found that when increasing the roof height, the presence of a buoyant force can improve thermal comfort due to the increase of turbulence kinetic energy, which that around the wind speed become higher around building. Another research mentioned that the flat roof building at a street canyon has a good performance to improve the ventilation urban areas. So the another benefit is a low air temperature. A number of research concluded that when the position of a taller flat building in upstream of the stream canyons, the air temperature will become lower. So this is a good result in order to improve the tendency level wind speeds. However, the private study should more focus on the exploitation of a building surface temperature or thermal turbulence around building. So mostly they are focused on the temperature of building in so it's more they need more patient for the focus on the roof shape for building. The another advantages of good design roof shape is improve the thermal comfort environments. In general, it's not that the roof shape design can influence the wind speed around building. The private study concluded pitch roof can improve the thermal comfort by the Hostins and the Huiwen 2017. In summary, this result show that the cool performance of this towards the tendency level wind speeds. Tendency level wind speed. This is in the chapter 2, digital review. The key factor that affected pedestrian conform is the wind environment surrounding the building. Moreover, Liu has reported that the mean wind velocity ratio is used to evaluate the wind environment and pedestrian level. The condition of a surrounding wind and the pedestrian level is affected by the roof shape. So from here we know that these roof shapes can bring effect to the pedestrian level wind speeds. The pedestrian height for wind speeds is 1.5 meter above the ground at urban. So this is pedestrian height. We know that the limit is from 1.5 until the 2 meter.
So for computational field dynamic, in recent year, the CFD have successfully contributed to the application of wind flow around the building by providing a suitable way for the determination of mean flow conditions. So this shows that the CFD have a very good performance in order to predict the analysis of to predict the velocity around the building, and also it can provide a very detailed data of energy level around building. So it is a powerful tool for the analysis of a building. For methodology, the below figure shows that the methodology for chart of the study. The first one is the site selection. So we have to select the site for this study. I'm selected the campus Pago UTHM as my site to be analysis the wind speed. This is because the building at Pago, the higher capacity and also the building arrangement, the shape of building, it can be matched with the urban areas. The next one is the roof building identification. So based on the building at the Bago, we have to identify the roof shape of building at that. For the building plan of the building at Bago, it is taken from the website of Wikimap. So the next step is to develop the 3D model. For this, we can using the AutoCAD and also the Ants design modular in order to design the model of building. For the simulation setup, using the Ants software to carry out the simulation. So another is validation of CFD. So after we getting our result, we will compare with the validation of CFD model, which is from the AIJ model. This is an guideline and standard of Japan, from Japan. So we will carry out the CFD simulations after this, and also the wind speed ratio. For wind speed ratio is a ratio for building with and without of ratio. It means that the wind speed across the building will divided with wind speed without building.
As just now mentioned that this is the simulation setup or the guideline we have to follow in order to design our model. The first one is the domain size. The ratio of the block edge should be below 3% when design the size of computational domain. Oh, before that, I have to say that in order to determine the prediction of pedestrian level wind speed by using the simulation of CFD, this guideline should be used for the turbulence models. This is based on the result of benchmark test. The guideline above is proposed that by the group of the architecture institution of Japan, AIJ Yoshihide dominated. So it is Japan architects have designed this guideline in order for the stimulation of CFD. The second one is the grid resolutions. The building scale should be set at minimum to above 1/10 for the grid resolutions. For boundary condition, the outfall boundary around building should be set far away for the area that is affected by targeted building in order to determine the accurate of result. For turbulence models, some research reported that the reusable KE models were suitable for the prediction of velocity due to its less of computational case and requirement of a small number of grid resolution. So RANS K models can provide very accurate data of prediction velocity. So this is the validation of CFD model based on the benchmark from the AIJ group. So after we are getting our result from the simulation CFD, we have to compare it with this result. This showing that the diagram of measurement point of the single building. For this project, we are going to carry out the analysis of wind speed at two types of building. The first one is the single or isolated building. The another one is the multiple building. So based on this result, we will compare it with the data from this AIJ guideline. This is another picture that about the multiple building. So you can see that the arrangement and also the standard guideline. For the expected result, based on the result from the private study, it is found that the roof shape, gable roof, and pitch roof are commonly used for the prediction of wind speed
and CFD distributions. So below figure show that the roof shape, flat gable, domes, pitch steps, and this is their effect on the pencil level wind speeds. For gable, it shows that the thermal conform, the thermal effect of the roof and buoyant force inside the cayon cause the formation of vortex, which can lead to the buoyant force, and also the high kinetic, the thermal buoyancy and turbulence increase the turbulence kinetic energy, which can improve the air ventilations. The another is the gable. By only increasing the slope of the roof, the vortex can perform a better, which led to the higher turbulence kinetic energy near the roof surface. For dome shape, the magnetic of vortex decrease and produce a low thermal buoyancy and turbulence. As a result, it shows a poor performance to pedestrian level wind speeds. For pitch roof, results show that the pitch roof with low pitch will reduce the ventilation and causing the wind velocity and turbulence become lower. However, a research concluded that the pitch roof can show a good performance in the wind flow and air exchange. So for step roof, based on the table 2.1, as mentioned just now, it showed that the mean velocity of step roof is lower as compared to other roofs, which is the gable and also the flat roof. So based on prior study, we expect that the optimal roof shape design toward pedestrian level wind speed will be established. That's all of my presentation today. Thank you very much.